Hi, I'm Elisa Kimball, and I'm here to talk about human embryonic stem cell research and the issues surrounding it. Currently, since the 1970s, the United States has in storage over 400,000 human embryos. Each year, another 20,000 is added to that storage. These embryos are used for in vitro fertilization and for research purposes. What is a human embryo and the stem cells? Human embryo is an ovum that is fertilized, and within 4 to 5 days it is cryogenically preserved and frozen. At this stage is called a blastocyst, and it is a pluripotent cell that can be used for research purposes. Researchers can extract out cells into the 3 primary germ layers, the ectoderm, endoderm, and mesoderm, which is responsible for the circulatory system, the nervous system, and the immune system. Over 220 stem cells can be extracted from a human embryo. Researchers can use these stem cells to advance treatments in medical therapies and drug therapies for genetic diseases such as diabetes, cancers, Parkinson's disease. Testing on human embryonic stem cells has caused many controversial issues. In this presentation, I will cover those controversial issues, some of the legislation that has tried to be passed that bring it to the public eye, and alternatives to using adult skin cells instead of human embryonic stem cells, and the importance of continuing human embryonic stem cell research. The most controversial ethical issue surrounding human embryonic stem cells is the point at which life begins. Scientists and physicians both differ as to when life begins. Scientists at this stage of a human embryo says that life does not begin because it is not viable on its own. Other moral and ethical leaders argue to say that a human embryo is a human life at the point of fertilization. Because these debates continue, the ethical issues surrounding this type of research will continue until human life, at the point at which human life can be determined. Because there is no federal funding for human embryonic stem cell research, several states have tried to pass legislation evolving around stem cell research with human embryos. Examples of that: Michigan voters rejected legislation that would allow spare embryos to be used for research. Voters rejected that. Colorado, voters rejected legislation that defined an embryo as a human life, and thus any testing would become a criminal act. California voters passed legislation that would allow state bond funding to be used for human embryonic stem cell research. This shows the vast differences of public opinion with human embryonic stem cells. Advocates of stem cell research have indicated using mature adult skin cells as an option instead of human embryonic stem cells. The differences are limited. The adult stem cells, only 1 in 100,000 cells are stem cells. At this point, researchers are determining to see if adult skin cells can be reprogrammed like human embryonic stem cells in order to provide multiple stem cells within the primary germ layers. This presentation is to inform you of the importance of human embryonic stem cell research and the issues surrounding it. The possibilities of evolving adult stem cells and using adult stem cells can be vast and need to continue so that they can be compared, and human embryonic stem cell research can be used in addition in order to provide additional drug therapies and gene therapies for genetic diseases. Are there any questions that anybody has in regards to human embryonic stem cell research?
Yes, Mrs. Kimball. Who owns the current pool of human embryos that are cryopreserved?
The current pool of cryogenically preserved human embryos are owned by private donors awaiting in vitro fertilization, people who have donated their embryos for research purposes, and orphaned embryos that donors have used and no longer need for in vitro purposes.
And one last question. What is the difference between adult stem cells and human embryonic stem cells?
Adult stem cells can be easily obtained from any mature adult. They can be obtained from the bloodstream, from the skin, and from neurocells. They're easily obtainable, and the process of extracting is very simple. On the other hand, human embryonic stem cells, it involves a female donor stimulating their ovaries to produce as many ovums as possible. Once those ovums are extracted, then they need to be fertilized and then cryogenically preserved within 4 to 5 days. Are there any other questions?
No, thank you.
Thank you. I hope this presentation provides information as to human embryonic stem cell research and the issues surrounding it. Thank you very much.